Go, go. There we go. Hey, welcome everybody once again to Astronomy Daily Live. Astronomy. I One of the things that I am compiling is data on the words that are said during these live streams. I guess I guess you can sort of say, primarily by me, but it's basically the transcript that YouTube creates. And so I've been slowly accumulating this data over the past, well, I've got a year and a half's worth of data. I don't have it all. I don't think I even have a third of that. But yeah, it's kind of interesting what comes out of that. So yeah, when I say a word over and over and over again, I'm biasing it up a little bit. So astronomy. All right, well, hope everybody's doing well out there in the universe and the world. Everything's good here. Hey, Tom, nice to see you in the chat and on the panel. Once again, from the deep south, Bobby, hey.
Well, it's just not Beetle guys.
Well, it is now. Yeah, because what I do is I take the transcript and I have a little program that counts the number of times words are said. So, like the word astronomy, okay, that when I say that word, its count gets bumped up 1. So, yeah.
Good time to use the thesaurus.
Yeah, it's just really, really interesting, So, a 60 to 90-minute live stream will produce a certain number of words, and I can calculate like how many words per second I'm speaking, and I'm around 1.7, 1.8 words per second, which is actually very, very slow. I've done this kind of analysis on other transcripts, and a lot of them are around 2.5 or 3 words per second. So just talking really, 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 really fast.
Yeah.
And
yeah, go ahead.
Oh no, go ahead, Bobby.
Oh, okay. Yeah, but the sad thing about it, around my location, is we're going to get some thunderstorms tomorrow.
Oh, wow. Hey, I just noticed on my Hangouts screen here is a little blue box in the upper right, and I know that you all can't see it, but I'm going to read it. So
okay.
it's a little blue box. It says, "Hangouts on Air is going away later this year."
Holy crap. What the heck we are going to do now?
Well, what they are suggesting is a link to a thing that they called quick streaming. And I'm going to click on that link and let me look at it really, really quick just to make sure that there isn't anything incriminating. Because we wouldn't want that now, would we? So what I'm seeing right now is just oh, okay. There it goes. YouTube wants to use your microphone, use your camera. Okay, I will allow that. Webcam stream info. Okay, well, maybe this is the way to go. I did not know about this. I should give this a try. So I think what I'm going to do over the weekend is I'm going to give this a nice shot because I didn't know that this existed, but
Okay. But
I'm
will
sort
you
of
but will you have a panel option in the quick stream? That's the thing.
yeah I don't know that. So yeah, what I'm
So
going to do is I'm going to bookmark this page just like that, and then I'm going to get rid of it because yeah, let's do some astronomy. Let's not worry ourselves too much over that weirdness.
yeah.
Okay, well, cool. Yeah, Tom, I want to move to Twitch, like I've wanted to for um, well over a year, 2 years at least. I've wanted to move on to Twitch, and well, um, this system just cannot handle that kind of bandwidth. I've tried it. I can run OSB, and I love OSB, or OBS. Is it OBS or OSB?
OBS.
OBS. I love OBS.
Yeah, I
I
can. I don't think I can get OBS working on my Chromebook as
Oh
well.
man, I love it. There is such a great way to control different views. Oh man, I wish I had that. Right? I wish I had that. Um, but it overwhelms both my machine because it has to render.
So,
Um,
Uncle Bill, do you think a Samsung Chromebook 3 would be great enough for OBS, or do I need like a badass hardcore machine and stuff?
I think it would be best, at least in my opinion, to have the most hardcore machine you can have. Yeah, lots of memory,
Yeah,
like
yeah,
16 gigs, 32 gigs
yeah.
of memory.
That's what I fear and stuff like that.
Yeah, but yeah, because it just, I mean, so um, if I were to be able to use OBS, I would be on Twitch in a microsecond. Yeah, yeah, because I think that's probably more, possibly more uh, my/our kind of crowd. Not quite sure. It's a little bit more casual over there. YouTube is oftentimes, really, really scripted and edited and everything else. And I know that there's a lot of live streams here, but even those are very structured. Um, Even the live streams. This is this is not structured in any way at all,
Yeah,
except that I like to keep it to astronomical, spacey,
yeah.
sciencey things. So
If Twitch would have like an amateur radio category, I would definitely be on Twitch, and Jills would be on as well.
yeah, yeah, no, so I would absolutely love to be on Twitch. I would jump onto Twitch right now if I could, and
Oh
just
yeah.
completely abandon this one totally.
Okay. Just out of my curiosity, your boss is a ham, right? Did he ever
Yeah.
want to get into GMRS, General Mobile Radio Service operations?
Oh, I have absolutely no idea. I would have to write that down and ask him because he probably knows what that is.
Yeah, because what's also good about GMRS, and I talked to someone who owns a repeater, and I doubted him because I once did talk to him on Facebook, is that he's going to set up a GMRS repeater. Now, I think what's good about getting a license is just $75 for 10 years, and you can just go ahead and start talking once you get your license.
Yeah, very cool.
No test needed.
Very cool. Wow. So you can just buy them off now, huh?
Yeah.
Wow. What a world. What a world. As long as you have enough of these, you can get anything you want. That's
Yeah.
great. Yeah. Hey, so I just wanted to let everyone know that Ata is right at this moment outside in the dark with her telescope, and she is looking at things. So she posted a note over in the Discord server, a link to which, excuse me, is right below. Um, so yeah, she is doing exactly the right thing and doing something that she really wants to and is not here. That's extremely wise. So yeah, she's out observing. I fully expect a full report when she gets back. So I think, I mean, she's doing exactly what um, you know the amateur astronomer should do, and that is go out every single clear night, because those are in most parts of the world those are pretty almost rare. So yeah, when you have an opportunity to do it, do it. Yes.
Yeah.
All right. Well, I have the dihydrogen monoxide today because I'm thinking that I'm going to stay up and maybe do some Jupiter observations, but I haven't really decided yet. So I've got time. I've got about 2 hours. So yeah, that's plenty of time to decide on that. I sort of have to. Yeah, I I know that I can, collect the data that I need, but I still not quite sure what I'm going to do with it. So I don't necessarily like to collect data just to collect data. That's not really in the scientific process. Um, the scientific process involves the follow through and the analysis of the data, and um, hopefully uh, um, uh, helping the data show certain interesting things. Who knows? It could be a surprise. Um, it it could be the same old story. Um, Whatever it is, it's news, and yeah. So all that is worth doing, I think. But yeah, I just have to think about it because it's the thing that I want to do there is quite a commitment. So I I'd want to follow through a little bit more than what I've done in the past. So, all right, well, cool. Let me check the chat here. So, Tom, I said hello to Uncle Bill. Nightbot
Okay, so
is
on this day in 1985, the Vega 2 space probe, which is from Russia, released their lander to the surface of Venus. The lander transmitted data from a scientific payload until it failed after 56 minutes. Surface condition reported included 91 ATM and a 463 Celsius temperature. What's the ATM?
That's atmospheres. So 91 times the atmospheric pressure of the Earth at sea level. So that's a heavy atmosphere. Yeah, that just crushes. I don't think that you can push that hard. I mean, you would start to easily break bone, I think, at those kinds of pressures. These
Crushing.
these yeah these spacecraft were crushed like tin cans, just and melted. Yeah, yeah, and
Yeah,
burned.
I think that's also true in Mercury. You can't just like get those things into those planets.
Well, Mercury's an interesting case because it has a really thin atmosphere. So on the sun side, it's really hot, and on the dark side, it's really cold. And right on the terminator is sort of this in between thing. Um, and the interesting thing about Mercury, its rotation and its orbit. Um, I, I don't remember the exact details, but on Mercury, the motion of the sun in the sky isn't like this east to west thing. The motion of the sun in the sky, I think, makes more like a figure eight. I think so.
Mm.
It's really weird. Really, a really
And
weird place.
you know,
So
it's also weird that if it was had the ability to crush it like the lump on the Mario games, I didn't know why it didn't crush the ship of the imaginary from Carl Sagan's Cosmos.
well, because you have to use your imagination and be like, no problem, no
Mm.
problem. We are not going to get crushed because we're just imagining that we're not going to get crushed.
And
So
I
that's
think
it.
that's the cool thing about the Cosmos series is the ship and imaginary, that little stored like ship that is always going around and stuff.
It's supposed to be a dandelion seed, right? It's like a puff.
Okay.
It's like a puff. So yeah,
And like and so like the dandelion compared to that
right.
little spear like in Tyson's Cosmos, that's pretty darn crazy.
Yeah. No, I like the dandelion seed much better, and yeah, that works really well. And he it it was absolutely brilliant to be able to do that because he you know he he completely set the context for speculation. So when we went into the ship of the imagination, we were in sort of a virtual universe where we could see things that we couldn't possibly see, and do things that we couldn't possibly do. Um,
Yeah.
yeah, and speaking of Mercury, right now is a very good time to see Mercury in the evening. So go out. Um, I don't know, maybe starting half an hour after sunset or so, and look almost due west, and you will see a very bright, um, well, not as bright as Venus, but pretty bright, maybe about as bright as Saturn. So pretty darn bright, but that is Mercury, and it's about as furthest east as it's going to be this time around. So
Yeah.
yeah, I don't know. what the exact date on that is, but I think it's coming up here pretty soon. So you've got another week and a half or so to be able to sort of easily see it. And of course, it's coming around, and it's actually going, right now it's trying to catch up to us. And when it does, it'll be right between us and the sun. And so trying to see it with the sun up is virtually impossible. There are ways to do that, but from the ground, no. All right, well, cool. So,
Oh,
cheers.
all right. Yep. Prost.
So yeah, I will have to check out this YouTube quick streaming. I'll be doing some experiments over the weekend and see, maybe they have, some features that are similar to OBS. Don't know. I'll have to find out. So stay tuned. Yeah, I'll keep you posted on that.
I hope it does have a panelist option because I'm gonna miss the panel watching if it doesn't.
Yeah. That like I keep saying about the panel and stuff. I think that adds a really really nice texture to the live stream. Because if it's just me, I mean, I can nerd out on these things and just go who knows where, right? But if we have a little bit of interaction and a little bit of tangents and all that, it just keeps everything nice and fresh. So yeah, I like panelists too. I really, really do. I think I would probably enjoy being a panelist. I think. I never have been. So I don't know what it's like on the other side.
Well, yeah.
All right. Well, cool. Hey, I was looking at the orbital data that we grabbed yesterday from the JPL Horizons website, and I was, I've been looking at the data in different ways. I've been having a little bit of fun this afternoon, looking at all that and thinking about, what is possible in terms of working on this data a little bit more. But one of the things that I did was just a very, very simple plot. And I found something that looks wrong. And I just wanted to show off, I'm just sort of right in the middle of things here. So I'm not necessarily looking for any kind of help or any kind of explanation or anything. I just want to show you sort of where I am in all of this. And so let me, let's see, am I ready to do this? Yeah, okay. Nothing incriminating on the screen. So share that, go there.
Oh, yeah, I can definitely see that blue box.
Yeah, there it is. Okay, so what? Oh, let me put this here, and then we'll put this on top of it, so there isn't a lot of motion and stuff. Okay, so let me explain what this plot is, and actually, let me make this a little bit bigger. So just excuse me for just a second. I want to make this bigger.
Yeah. And it sucks getting sidetracked.
Okay.
You get sidetracked, and the next thing you know, what? Whoa. What am I supposed to be doing? What am I supposed to be doing?
Hold on, folks. Just 1 second. There's a ruckus that I cannot account for. So hold on 1 sec. I will leave you in the wormhole.
Oh. I don't know what's going on in the wormhole, that's for sure.
Javelina. All right. I don't know about some people. Some people. Okay. Let's get back to
Some people's
some
freaking
some
shape.
some people. I'm not going to mention any names whatsoever. Okay.
So maybe put your chat on the other side or make a terminal
Oh yeah.
window.
Yes. Oh, sorry about that. Sorry about that. Actually, you know what? Dang. Okay, so that's about as big as it can get. What this is the orbit of the Earth going around the sun, and this is the orbit of the asteroid, 1999 KW4. And shoot, you know, from this perspective, when I look at it from this perspective, well, hold on. This way. Oh, okay. Oh, okay. Well, that is all right then. What was confusing me, and what I'm still a little bit confused about, is do you see these two ellipses? There's a black one and a red one. This green dot is the position of the sun. And as I said, this is the asteroid, and this is Earth. And I guess what was confusing me is that the sun seems to always be in the center of the Earth's orbit. But as you can see, as I rotate this thing around, the sun doesn't look like it's at the focus of that ellipse. Do you see that? I mean, to me, you know, the focus of this ellipse is about here, or maybe here. So, yeah. Anyway, I just wanted to show this off because I'm a little confused. See, but if we look at it straight down, then that looks like it's in the right place. So, yeah, maybe I'm just not looking at this right. Yeah, see, I guess that's what confuses me. Is why isn't this down here? Yeah, I don't know. I'm confused about what I'm seeing. I'm not quite sure if I am looking at what I should be looking at or not. So, yeah, all right. Well, that's sort of that craziness. Always fun. So yeah, you know, I thought maybe what we could do is go back to Aries, but do something kind of different. As you can see here, I've got the HST data search form here. And usually what I've done, at least on this live stream, is I've just typed in a target name of some sort. And, you know, we've searched the HST data for that. But there's another option, and that is to designate a position in the sky and a radius, and have it report back all all data that is within that circle in the sky. So I guess what I'm suggesting is that we do that for sort of at least a moderately large piece of Aries, and see what targets the HST has looked at in the constellation of Aries. Sounds kind of interesting. So we need a right ascension and a declination. So we can go over here to the Wikipedia page, and let's just choose more or less the center of the constellation. Okay, more or less about there. So I would say that that's a right ascension of about 2 hours. Let's just say 2 hours, 30 minutes. Okay. 30 is exactly halfway. So yeah, that's kind of close. So let's go with 2 hours, 30 minutes for the right ascension. And I think, 0 to 30, 0, 0. I'll go ahead and just do that. So that's hours, minutes, and seconds. And then the declination looks dead on plus 20. So let's do that. Plus 20, 0, 0, 0, 0. So that's 20 degrees, 0 minutes, 0 seconds. And let's increase this radius to 30 arc minutes. So that will give us a 1 degree diameter area, which on this scale is just about like that, I would say. Something like that. Yeah, in fact, here's 1 degree. So yeah, a pretty small piece here. But let's look and see if HST has looked at anything in that area. So we'll take a look at everything here. I don't expect anything. I don't think anything's going to be there. But let's, this is something that I haven't actually done this in a long time. So so let's just sort of see. This is sort of kind of random. Here we go. Bam. Nothing. Okay.
Crap.
Yeah. Okay. Well, you know what? Let's move up to like plus 25. Let's not give up so easily. Nope, nothing there. Ooh, let's go up to plus 30. Ooh, that's just barely touching up here. Let's see. Oh, nope, nothing. How far can we go down? We can go down to 11, right? 10 is outside, technically speaking. So let's do 11, right? So plus 11. Got to be a little stubborn here, Nope. Shoot. 15. Dang.
What the crap?
17. Oh, look at that. We got one.
Hey, we got a bite.
We got a bite. Taken back in 2008 and 2006 with Pick 2 and Nick Moss. Nick Moss is an infrared camera, kind of low resolution. I think it was, 256 on a side. But Pick 2 looks pretty interesting. So I wonder what they're after here. The target name is 19299. What the heck is that? Should we look?
One way to find out, my
Alert.
friend.
Alert.
Uh
Oh, hey, there's Mr. Earth just in time to look at this completely who knows what this is, HST target. So this is
Okay.
this is in the constellation of Aries. I was just thinking about looking around and seeing if HST has looked at anything in the constellation of Aries. So we've been trying and trying and trying, and we finally got a little bite here. And we were just about to hit this button when there was an Earth alert. So I had to stop and say howdy.
Perfect timing.
Perfect timing. All right, so
I wouldn't want to miss this.
I have absolutely no idea. I do not know what 19299 is. I don't have a clue. So let's find out. Don't expect much. Don't expect much. Have no expectations. Here we go. You ready? Oh yeah, look at that. That's just nothing. That is absolutely nothing as far as I can tell.
So is it something that's out of our view? Is it something there that we cannot see?
It's a star field in the constellation of Aries. Let's look at the proposal and see what they're up to. So the discovery of binaries in the Kuiper belt and related small body populations is powering a revolutionary step forward in the study of this remote region. Okay, so they are searching for binary asteroid systems in the Kuiper belt. Very cool. So yeah, and that sort of explains this now, because they are looking, you know,
that's kind of what we were talking about before with the double asteroid, right? I think we were talking about that.
Yes. It turns out that there are sort of an unusual large number of binary asteroids, kind of, and nobody really understands why. It's got everybody just scratching their heads, going crazy. So yeah, so my guess is here. Let's look at the exposure time. So 260 seconds. So pretty long exposure. It looks like they took the same exposure time, same filter, same everything, just different times. So you sort of see how they did this one at 11:35, to 11:39, and then they did another one right away, and then oh look, they waited like an hour and a half, and then they did another two back to back, and that was it. So that was their let's see, 260. I've grabbed my calculator here. 260 times 4 divided by 60. So that is their 17 minutes and 20 seconds of fame. So yeah, probably what they were doing is, they took these exposures and they took these exposures, and then to look for anything that's moving, one of the easiest things to do is to just take the difference between them, subtract one from the other, and things that are exactly in the same place are basically going to subtract out. But if there's anything moving, you'll have a very, very bright spot and a very, very dark spot where that subtraction took place. So it's pretty easy to find things that way. Anyway, so that's probably what they're doing here. So this was taken, and I mean, this is really, really. I mean, this is what the data looks like. It's got all these cosmic rays. It's got bad pixels. It's just nasty. It's just nasty stuff. But that's how it is. That's how it is.
So what is the asteroid? What is the asteroid belt from?
Oh,
the main one. The main one.
I'm not. I don't know exactly what the current story is on that. I guess my understanding was or is that sometime in the past there was some kind of either tidal forces that broke a planet up, or there was some kind of a collision. But yeah, I don't really think anybody really knows. And yeah, that kind of knowledge goes way beyond my database.
Yeah. I was just curious.
Yeah, I don't know. I don't know. Let's look at another one. So these two are probably going to be about the same. Let's look at this one and see if there's any difference whatsoever. Yeah, just different cosmic rays. But wow, I wouldn't be able to tell if there's any difference between those two or not. So yeah, well, definitely, probably not one of the more interesting looking HST images that I've ever seen. So, but it looks like they're doing some interesting work. I don't know if they were able to get anything out of this data. I guess I hope so. So yeah, I mean, they're saying here that they're expecting to discover at least 13 new systems. So wow, I don't know if they did or not. Don't have a clue. But this data was collected back in 2008. So yeah, almost 11 years ago, almost. So then we got this one, and this is the Dick Moss. So let's take a look at this. I have no idea. It's kind of sort of close to where these guys were looking. You see the right ascension and declination here? They're sort of kind of close to one another. So I don't know exactly what's up there, but let's look and see. Now this will probably look pretty terrible too. So no expectations. Okay, so it's a bright star. And what you're seeing are
something, Johnny.
Yeah, and what you're seeing with all these blobs and all that is optical effects. So these are caused, all these lines, all these bumps, all this weird geometrical patterns and stuff here. That's all caused by the internal optics of the telescope itself, and probably this detector. So yeah, that is just a single star, but its light is sort of being diffracted and spread out. So it looks, I mean, I think it looks really, really cool, but it is just a, what you would call a point source. So, but yeah, all that is caused by the optics, the optical path. And this is also looking.
They actually flipped onto that. No.
They actually what?
They actually factor on that little mask that you have for your telescope.
Hmm.
The Batman mask.
It does. It does. It looks a lot like that. And actually, this pattern, you could actually take that pattern and sort of work backwards and figure out what things in the optical path are causing all of that. So I mean, they know about this. This isn't a surprise, I don't think. So, well, let's look at this other one. Whoop, we're really zoomed in here. Woo.
I'd Ray.
There we go. Okay, so here's, yeah, okay, so that looks about the same. I think it's a different wavelength. Yeah, see, here they were looking at about 17,000 angstroms, and here they're looking at about 11,000 angstroms. So both way in the infrared. But and you can see, there's a difference in exposure times here too. Kind of interesting. So let's find out maybe what they were up to. I don't know if they'll say what they're doing, but we propose to extend the most sensitive survey yet undertaken for very low mass companions to ultra cool dwarfs. They will use NICMOS to complete imaging of an all-sky sample of 87 L dwarfs. L. So I guess those are the ultra cool dwarfs in 80 systems within 20 parsecs of the sun. So what? That's about 64 light years, something like that. So relatively close to us, right? Really, in fact, really close to us. Okay, so I guess this is part of looking for these low mass companions. So this image may contain the image of a low mass companion to, I guess, this star. So yeah, that's about as far as I can go with that. And even what I've said is sort of speculation, but I assume that these are the stars that they're talking about. So pretty cool.
Yeah.
And let's see, they got, how many minutes of fame did they get? 895. Huh. So 895.895, that's a little weird, plus 287.833 divided by 60. So they got about 19 minutes and 43 seconds. Wow. On that guy. 2 exposures. Yeah, well, you have to think about the HST too. It can only look at one particular object for probably about maybe 30 minutes max, continuously, because then, it's going around the Earth, and so the Earth is getting in the way, and it can probably only point, so far down. So yeah, I'm sort of thinking, max 30-minute exposures. So I don't think, and this is just a conjecture, I guess, but 30 minutes times 60 seconds, so we'll probably never see an exposure time longer than about 1,800 seconds. I don't know if that's true or not. I don't remember.
So they got 30 minutes to get what they want before the Earth obstructs it, right?
Yes. Yeah. So yeah, they got about 20 minutes here. So yeah, that's I think that's about right. 20 minutes is really, really safe. 30 minutes, I mean, it takes the HST, what, about 90 minutes to go all the way around. So that means it's 45 minutes to go halfway around. So yeah, I think 30 minutes, I think that's probably about right. Cool. All right. Well, that's kind of neat. I really wasn't expecting to have HST looking at anything, so that's kind of neat.
Yeah.
I'm kind of wondering.
Now,
Oh, go ahead, Bobby.
I was if you was not continuing, I was wondering if you ever showed Ron your slide rule before.
Oh, my slide rule? I don't know. Have I ever shown you my slide rule, Ron?
I think you showed it when you got it. You had it in a cover, and then you showed it. And you said, "This is the." I think this is my real calculator. I think you said something like that.
Yeah, it's got a very interesting story. Let me very
I don't
interesting
know. I don't
story
know enough about
associated.
slide rules. I know what they are. I just don't. I don't quite understand them.
I'm gonna reach up here and grab it. So there it is in the case.
Yeah.
It's got
Okay.
Is that upside down? I don't know what it says. Oh yeah, it is. It's a Dietzgen.
Okay. All right.
All right. Anyway, so there it is.
Okay, so how does it work?
This part slides. Well, it uses a logarithmic scale. It uses logarithms, different kinds of logarithms, to allow you to do practically everything. The only thing that you can't do with a slide rule is add and subtract.
Oh no!
But you can do practically everything else.
How would I figure out my gas mileage then?
Well, okay, now gas mileage is a division, so we could do that.
Okay.
Because a division is also a difference of two logs, so two logarithms.
Okay.
For instance, the ratio. Am I doing this right? Let me make sure I'm doing this right. Well, anyway, here's my story about this. So, in the 8th grade, when I was in the 8th grade, calculators were just sort of becoming a thing, and of course, calculators were banned, right? Just absolutely banned. You can't
use them in the class. Yeah.
You cannot use a calculator in class.
Yep.
I said, okay, no problem.
That was your calculator.
I got my slide rule, and I knew just enough to be able to do everything I needed to do, and it was easy to add and subtract, right? So easy. So I brought this in to class, and my teacher saw it, and he looked at me, he looked at it, and he just kept walking.
He didn't know how to answer it because it wasn't a calculator. It had no power.
He understood that in order to use a slide rule, you have to know numbers really, really, really well, because the art in using a slide rule is keeping track of your decimal points.
Okay.
That is the real art here. That's why it can be so compact.
So all right,
because,
I know the answer to this one. You have 888 miles. Okay. My
right?
car gets 17 miles to the gallon. There's your two numbers. What do you do?
Oh, do you want me to do it right now?
Yeah, if that's
Oh
easy.
man.
I don't know how easy it is. I mean, I know what the answer is. I just wanted to see how you could come up with it on that.
Oh man, I don't know if I remember exactly, but I'm gonna try.
Or you can save it for next time if you want.
888
8
divided
by 17. Yeah.
888.
Yep.
Okay.
That's
So
miles to Charles' house in Ohio.
so I've got it on. I've got this pretty close to what I would call 888. I think
Okay.
I've got this right. So now I set this to 17,
Oh.
which would
And it
be
should give you an
over here. And if I read this thing, see,
come get close. If
well,
I get right.
is the first number a 1?
No.
All right, well, I'm doing it completely wrong. I haven't used this in
Okay, so maybe
too long. But I
when
mean,
is your next show?
all right.
That's your homework. That's your homework.
I'm gonna take that. I'm gonna take that challenge. Hold on. See what you get me into.
I use the calculator to figure out mine, so I don't know. Oh, there you go. The manual.
Yeah, I don't know if it's gonna show me what I need to know though. Ooh. No, it's not. Oh, shoot. This is just like a maintenance.
So in the basic equation, just doing a calculator, you have, I believe it was 52 point something per gallons of gas. Okay.
Okay,
So
well, let me line this up
round
again. Hold on a second. Let me do this a different way.
Okay.
And see if I can get it.
888.
So there's that. And then if I do this, 17. I've got it. Yes. Okay. So I'm going to try to show you this. Okay.
Oh,
come on.
Okay.
Focus.
Yeah.
Come on, focus.
I can see. Yeah.
Okay. So you see where that 1 is right
Yeah.
there? It says C1. You see where the 1 is?
Mm-hmm.
Okay. There's a 5.
Okay.
There's a 2.
Yeah.
So it's 5, 2,
point something.
and then something.
Yeah.
So
Cool.
what I did is, come on, focus.
Well, I know you can make it work then. Cool.
Is I put this, see here's 8.
Yeah.
And then 8, and then 8.
Okay.
And then I put the 17. See, here's a 1.
Yeah.
And a 7.
Okay.
I line those two up, and then I look over here.
And that's your answer. Yeah.
And there's my answer.
Got it. Perfect. That worked.
I remembered.
All right. That's your extra credit bonus there.
I get the gold star today, huh?
That's right.
Wow.
But yeah, that's 52 point something, and I just for easy for my math in my head, I rounded it up to 53.
Anyway, this was the beginning of the end of my friendly relationship with all the kids in the class.
Yeah.
So because they thought I had gotten away with murder and that I was cheating.
Yeah.
And
Or
in
you're
fact,
way too smart.
the opposite was true. This is actually, relatively difficult to use because you have to keep track of your decimal points and you've got to line everything up exactly.
But
And
when you have
it's
the answer,
hard.
though, when you get the answer, though, it's more precise in reality.
Well,
No?
yeah.
Yes? No?
mm,
If you got all the right numbers and you got the right figures, you know?
this is good. I mean, for for multiplication and division, this is good to 2 decimal points, I would say.
All right.
So it's not all that great. But I think that
But
there, that is really, I think, only one way to do a division on this thing. I think that there are other ways that are actually maybe even more precise. I'm not quite
That's
sure.
the correct formula that I had, though, right? Divide 888 by the mileage that my car gets, correct?
Yeah, yeah.
And then that gives me a basic of how much fuel I'm going to use.
Yep.
So
Correct.
I figured out before I went on the trip, I figured out 52 gallons or so, and I just to round it up to 53 just to make sure I had enough money wise. I wouldn't really gas as far as distance, more worried about the dollar amount.
Yeah. Hey,
And so
Page Master, that was a nice thing to say. That is very cool.
yeah, so that was
Appreciate
fun.
that. All right, well, cool. I am looking at the clock, and I'm noticing that it's a couple minutes after the hour.
Uh-oh.
I need to decide if I'm going to do Jupiter observations or not. The wind is blowing out there like crazy. So
Yeah, it was windy
yeah.
here. Windy here today.
Oh yeah. So I don't know. It's pretty nasty. I've got another hour and a half before I have to sort of decide to go or no go. So I'm gonna keep an eye on this wind. I guess if the wind dies down, I will go out for at least a few hours and get some Jupiter observations. So
No,
see,
you should
the
have
moon
asked
is
the
near
weather.
yeah, I don't care about the moon.
You should have asked on the weather station that measures the wind direction and speed.
Well, it's all I have to do is sort of either look out the window here or go outside and I definitely know. I mean, if the wind is really blowing at all, it's a no go. Because it just jostles the telescope around too much, and that's
Yeah.
expected. That's expected. That's why a lot of telescopes are in domes, because that sort of mitigates that a little bit. So I don't have a dome yet.
Not cosmic though. No dome for cosmic.
No, not yet. Not yet. So, all right. Anyway, so having said all of that, I think it is time to exit these waters. So I'm glad everybody was able to stop in.
I'm
Yeah,
glad I caught the end.
yeah, absolutely. So yeah, I'll be back here again.
And are you going to be like over the weekend going to test that little stream alternative?
Yes, I'm going to be doing that. I have no idea when. If you catch me, you catch me. If you don't, you don't, because I mean, those kinds of things are test things that I'm just going to delete. So if you catch me live, great, I suppose. I mean, it's about as interesting as this. So
Yeah.
Yeah.
all right, everybody.
It does suck if it doesn't have a panelist option.
Yeah, well, I will try to find all that out. That is definitely in my lap to find out. Google Hangouts, I guess, is going away. But I guess there is a
Really?
yeah, but I guess there is an alternative, and so I'm going to check that out over the weekend.
What's the alternative?
It's UCAM.
Oh, okay. 'Cause I just use OBS and I use live stream on YouTube on the computer.
I wish that I could use OBS.
OBS uses a lot of resources.
I know that I don't have. It's just,
And then with the
this thing-
Wi-Fi, with my Wi-Fi and my internet here, it really takes a lot of energy and tasking to get it to go.
It burned a hole in the side of my house.
Oh
last
no!
time I tried doing it. I had to patch it all up over here.
Oh boy!
It's really a big mess.
Terrible.
All right, everybody. I'm gonna get out of here. Thanks
You
for
can, okay.
I'm
coming
gonna
in.
check the UCam too.
Yep, I'm gonna check that out too. All right.
Do it. All right.
Thank you.
Cheers, cheers,
See you
and all
next
that.
time.
Live long and prosper. I'll be back. 2 hours UTC. Thumbs up.
Remember, tell a friend.
Tell a friend. You.
Astros can just suck it.
Tell a friend.
You tell a friend.
All right, everybody.
Bye.
See you later. Bye.
Later.
Astronomy,
See you guys.
astronomy, astronomy, astronomy.